Hello everybody, I'm Mustafa Javadian, second year PhD student in hydrology under the supervision of Dr. Ali Berangi. My presentation is titled Drought Effect on Dust Storm Severity and Predictability. This project is a collaborative work with Dr. Ali Berangi and Dr. Armin Surushian. You might have seen beautiful cultural sites in central Iran, breathtaking nature in northern Iran, and of course modern cities like Tehran that is capital of Iran. But this is not the case for the entire country. We have also suffered from dust storms in southwest Iran that people call them the silent killer because of thousands of deaths. The World Health Organization (WHO) ranked Ahvaz, which is the main city in southwest Iran, as the world's most air polluted city in terms of PM10, which is defined as particles less than 10 microns. In this study, we aim to explore the origin of the southwest Iran dust events to quantify the relationships between major drought events in Iraq and dust events in southwest Iran. Finally, we want to introduce a satellite observed variable that can potentially be used for the prediction of dust events. At first, we need to know where are the dust sources for southwest Iran. So we performed an air mass backward trajectory analysis in the region to determine the sources. For each month of the year, frequency analysis was performed using 48-hour backward trajectory at 6-hour time steps. The left figure shows that dust storms, dust events mainly traced back to the northwest of the region, which is Iraq, in all months. For instance, in July 2009, about 80% of southwest Iran dust events originated from the central and southern part of Iraq. The trajectory analysis also suggests that in a few cases, less than 10% dust events over southwest Iran originated from Saudi Arabia and Syria, which was much less frequent compared to dust coming from Iraq. Motivated by the HYSPLIT results, two boxes were selected for further analysis. The red box is southwest Iran, and the red box is Iraq, and the black box is southwest Iran. The top right figure is the wind rules data from the Ahvaz weather station for a representative year 2016. It demonstrates that westerly winds are dominant in southwest Iran. The bottom right figure shows precipitation in Iraq based on weather stations. The figure shows Iraq receives much of its precipitation in cold months that mitigate dust sources over Iraq due to higher soil moisture. In contrast, in summer months, when there is much less precipitation, soil is drier over Iraq and can be a substantial source of dust. A similar HYSPLIT analysis was also conducted for the city of Baghdad, which is the capital of Iraq. The results showed that the main source of dust over Iraq originates in Iraq and only little comes from Saudi Arabia. Then we try to take a look at satellite data in the region. There are different aerosol optical depth products like MODIS, MISR, OMI, and aerosol, each of which has their own pros and cons. For instance, MODIS AOD has the best spatial resolution, but it has some problems in non-spherical particles. In this study, we used MODIS, MISR, and OMI AOD products to investigate AOD over our study area. So this is the spatial distribution of MODIS AOD over our study area. The red box represents Iraq and the black box is southwest Iran. As you can see in the figure, AOD in southwest Iran exceeded other regions of Iran, and also the fluctuations of AOD in central and southern Iraq was similar to southwest Iran. For example, in May, when we have higher AOD in Iraq, we also have higher AOD in southwest Iran and vice versa. And finally, the maps shows that dust events over Iraq are fairly isolated. In other words, the dust events over Iraq are produced locally because we can't see any connection between the AOD in the red box and the AOD in western part, which is mainly Syria. Now we can focus on the connection between Iraq dust sources and Iran dust events. At first, let's take a look at the mean annual AOD time series over southwest Iran. Both aqua and terra platforms were considered in this study. The results showed that year 2008 and 2009 were the most polluted year in southwest Iran. We also plotted the angstrom exponent. The angstrom exponent is a useful indicator for detecting aerosol particle size. Values greater than 2 represent small particles, but values less than 1 indicates large particles like dust. The angstrom exponent measurements from both terra and aqua satellites suggest that the pollution over southwest Iran is relatively more coarse size over the study period. In other words, dust particles are dominant in the air pollution of southwest Iran. For exploring the consistency of MODIS AOD product with other satellite AOD product, the annual AOD of Miser in southwest Iran is shown in top right figure. Comparing MODIS AOD product and Miser AOD product demonstrates that their AOD are relatively consistent, which adds more confidence in using MODIS product in the subsequent analysis. And also, the bottom right scatter plot demonstrates a good relationship between Ahvaz weather station visibility and its monthly AOD in year 2009, which again adds more confidence in using MODIS AOD. Although mean values can give a general sense of pollution, they may not provide sufficient information about pollution variability. For example, it's possible to have lower annual or monthly mean AOD, but at the same time more severe daily AODs. Therefore, extreme dust events were assessed by investigating the daily AOD from MODIS Aqua. We defined that a day with AOD greater than mean monthly AOD plus 3 standard deviation is an extreme dust event. The total number of these events in each year from 2003 to 2018 is provided in this figure. The result followed the mean annual result, but it can be seen that the number of extreme dust events in JJA increases dramatically and exceeds that in MAM for years with higher extreme dust events. For understanding the monthly differences in AOD over southwest Iran, we compared the average monthly values for 3 time periods, 2003 to 2008, 2009 to 2014, and finally 2015 to 2018. The monthly values show that in all periods, May, June, and July exhibited the highest AOD over southwest Iran. This is expected because these months are the hottest and driest months in this region, which can deplete moisture in the soil and make the environment prone to dust events. In contrast, lower AOD is observed in winter when the region often receives most of its precipitation and the soil is relatively moist. Furthermore, it shows that AODs in fall, especially in September and October, are higher in the recent period compared to earlier periods. This could be partly related to the fact that water bodies in the west side of southwest Iran and east side of Iraq have dramatically shrunk in recent years due to drought, especially in late summer and early fall. These wetlands almost went dry in fall seasons of 2015 through 2018 and consequently became a dust source for September and October dust storms in the region. The observed relationship between drying wetlands in Iraq and increasing dust storms in southwest Iran supports the idea that drought promotes dust storms. So we explored the relationship between drought and dust events using SPEI, separately calculated over Iraq and southwest Iran. SPEI is a popular drought index that considers both potentiality and precipitation. As you can see, the blue colors are more than orange colors, which means SPEI over southwest Iran is often more severe than Iraq in recent years. We also investigated the relationship between annual AOD over southwest Iran and annual SPEI over both southwest Iran and Iraq. It was found that annual AOD over southwest Iran exhibits a higher correlation with drought over Iraq in comparison to drought over southwest Iran, even though southwest Iran has more severe drought conditions. This makes sense given that most of the dust events over southwest Iran are are traced back to Iraq. SPEI is a popular drought index, but large uncertainties may exist in the quantification of precipitation and potential evapotranspiration. An alternative approach is to investigate vapor pressure deficit that can be calculated directly from temperature and relative humidity observed by Earth's mission satellite products. In this study, we used VPD as a proxy of drought. Therefore, it's important to investigate at what lead time Earth's observations of VPD over Iraq can provide the highest correlation with dust event incidence over southwest Iran. This figure shows the lag correlation between monthly Earth observation over Iraq and monthly AOD over southwest Iran. It demonstrates that higher VPD in Iraq for the current month would suggest a higher probability of dust events in southwest Iran for the subsequent month. Encouraged by the relatively good relationship between Earth observations over Iraq and AOD over southwest Iran, the potential of using Earth VPD observations to predict dust over southwest Iran with 1 month lead time was further investigated. We introduced this dust prediction model for southwest Iran by just having the VPD over Iraq. So in this study, we found that most dust events in southwest Iran originate over Iraq, and also we found drought over Iraq is largely responsible for dust events over southwest Iran, and finally vapor pressure deficit shows a skill in predicting dust events with 1 month lead time. We recently published this work in the Environmental Research Letter Journal. Special thanks to NASA for funding this project. Thank you for listening to my presentation. Feel free to ask me any questions at the Q&A session. Thank you so much.